Wait a minute, something going wrong. So, as per the syllabus, I will take care of Unit 4 of organic chemistry, reagents in organic synthesis. In the syllabus, we are having 10 reagents. 10 reagents we are having. We will discuss about its mechanism, selectivity, utility, means application of the particular reagents. As per the syllabus, this reagent this time we have introduced. Its name is HA2. This reagent we can use for the preparation of amides. Normally, if you want to prepare amides we can prepare by using or from acid and amines. This reaction may be catalyzed by acidic condition as well as basic condition. But when we carry out reaction in acidic and basic condition, means in normal acidic, suppose acidic condition with the support of sulfuric acid, during the reaction the water is formed. When water is formed, then amide can convert it into again acid and amine. So the reversible reaction will take place. To avoid the reversible reaction or conversion of amide to again acid and amine, we have to carry out reaction in the presence of certain special chemicals. That name of special chemical is known as HA2. It's known as reagent. How it having tendency or how it can be considered as a reagent, that we will discuss in detail with the name reacts with its particular kind of reaction. Next one is LDA. LDA means lithium diisopropyl amine. This one is known as base. Normally, when we are talking about base, in our mind NaOH is there or KOH. But sometimes these bases are not useful for some organic compound or some organic reaction, because due to the high acidic condition or due to the powerful or strong basic characteristic of this base, they can destroy or they can disturb the other functional groups too. So that's why other reagents we have to use. Its name is LDA, lithium diisopropyl amide. How it works in a particular reaction, again as I said, we will discuss with particular reaction and its mechanism. Then DCC, this one is the reagent which we can use near about 8 to 10 different reactions. 8 to 10 different reactions. This reagent, that is called DCC, is known as powerful dehydrating agent. Means DCC having tendency to absorb water. So whenever in the reaction water is formed and that water is interfering in the percentage purity or the product, at that time we have to use DCC. DCC having tendency to absorb water, that's why it is known as dehydrating agent. Next one is 1,3-dithene. It is known as Ampolong reagent. Now 1,3-dithene is the intermediate product, but actual name of the reagent is 1,3-propanethiodiol CH2SH. 1,3-propanethiodiol. So this reagent when we use for carbonyl compounds, normally in carbonyl compound the carbon having positive character or it acts as an electrophile, and the reason is oxygen is pulling electron. This one is known as electrophile. But by using this reagent and some other chemicals, we can convert this carbon into the nucleophile. So as I said, this one is electrophile, but by using this reagent, we can convert it into nucleophile. So we are changing the polarity or changing the characteristic electrophile to nucleophile, and that's why it is known as Pollen reagent or reversibility in the characteristic of particular functional group. Then next one is DMP, Das Martin per iodine. So now this DMP we can use for the oxidation of several organic compounds. Normally for oxidation what we require? We require K2Cr2O7, Na2Cr2O7, KMnO4, like reagents we can use. But these all reagents are chemicals are having transition metal, and transition metal having side effects, or we can say they are interfering in the aquatic life. Normally after completion of the reaction, the waste will be with the water. So water can be discarded or discharged by the industry to canal, and then ultimately it reach to river, pond, lake or sea. When it reach to the mainstream of water, at that time the aquatic life may disturb by the presence of these types of transition element. So to avoid such problem, we have to use some other reagents. Its name is DMP. This is an organic reagent, organic oxidizing agent, which we can use. Next one is Dibal H. Now Dibal H is used for the reduction of several compounds. It having selectivity, it can be used for the specific groups only, but yes, it is highly useful compounds. These compounds, that is called Dibal H, or this reagent Dibal H, we can use at different temperature from -78 degrees centigrade to room temperature, that is called 25 degree centigrade temperature. Based on the requirement of the reaction, we can set the temperature and we will get a different product with the support of Dibal H. Now next one is NaBH3Cn. NaBH3Cn is a specific kind of reaction or reagent. By using this reagent, we can carry out two reactions simultaneously, and that's why it is known as reductive amination reaction. So when we are using this reagent, two reactions will take place. One is reduction and second one is known as amination. Okay, so it is known as reductive amination reaction. The next one is DDQ. This also we can use for the reduction purpose. Then N-butyl lithium. Most of the industries are using this reagent for generation of carbon ion in a particular reaction. Then we can also use for the carry out the reaction that is called alkylation reaction. We can introduce various types of or length of alkyl group into an organic compound. This reagent is very much useful at industry level for various kinds of reaction. We will see how this reagent will be useful. And the last one is known as phase transfer catalyst. Normally, when we are carrying out the reaction may be in organic phase. Normally, we carry out reaction in organic phase. But sometimes some reagents are highly soluble in water. Means that is known as aqueous phase. Aqueous phase. And most of the organic compounds are soluble in organic phase. So now we are having two phases in the reaction. One is aqueous, another is organic. So here suppose this is your reaction mixture. In the reaction mixture, this one is organic phase and this one is aqueous phase. Now our target is to carry out the reaction. So our reactants are in aqueous phase, reactant, and the substrate is in organic phase. So it is very difficult to carry out the reaction. That's why we have to use phase transfer catalyst. Now when we are using the phase transfer catalyst, then what happen? The reactant, from the reactant, the reactive species will bind with the specific type of reagent that is called PTC, phase transfer catalyst, and reach into the organic phase. Here the reaction will be completed by the particular reactant, and then after the PTC will again transfer to organic phase. Aqueous phase. So it is called phase transfer catalyst. Suppose if you want to carry out cynation reaction, cyno group, if you want to introduce on organic compound, and your reactant is NaCN. So as we know, sodium salt of cyanide, that is called NaCN, is water soluble. But you would like to carry out a reaction that is called cynation reaction by using NaCN, and your substrate that is called organic compound is soluble in organic phase. Now it is difficult to shifting of CN from aqueous phase to organic phase. But when we add the phase transfer catalyst will bind with CN, and from aqueous phase, CN will migrate from water to organic phase. And then after the cynation reaction will be completed, again phase transfer catalyst will be free, and again it will reach to the aqueous phase. So it is a continuous cycle, and based on that we can carry out the several reaction. In mainly PTC, we can use a quaternary ammonium and phosphonium salt. Some extent crown ethers also we can use, but I will mainly focus on quaternary ammonium and phosphonium salt. These are having limitation, but even though it is in syllabus, so we will discuss at the end. Now I think I have given a brief information about the syllabus. So if you have any question, query in your mind at present regarding the what I have explained, then you can ask me. Otherwise we will move further. છે કોઈને question, query? મેં જે બેઝિક કોન્સેપ્ટ અથવા રિએજન્ટ્સ વિશે વાત કરી એમાં કોઈને કંઈ પૂછવું છે? ઓકે, આઈ થિંક મેં જે પણ વાત કરી છે એ દરેકને ખ્યાલ આવ્યો છે. અવાજ તો આવે છે ને હવે પ્રોપરલી?
Yes, sir. Yes, sir.
Thank you. So now I am going to start with the particular reagent. So first reagent is DCC, N-N-dicyclohexyl carbonamide. Now this DCC, as I said, it's a powerful dehydrating agent. So when I am talking it's a powerful dehydrating agent, means the name or term itself says it having tendency to absorb water. Dehydrating means it having tendency to absorb water. So this DCC will absorb water, means in reaction if water is there, then that water will be absorbed by DCC and the reaction will be completed in a forward direction. Now why we are talking about the reaction or this reagent? Suppose if you want to prepare ester, normally how we can prepare ester? We require acid. Okay, now here R equal to, let's say, example of benzoic acid. So if you are having benzoic acid, then ethanol C2H5OH in presence of acid, we will get or in presence of acid, let's say H2SO4, we will get product that is ethyl benzoate C11O OC2H5. This product we will get. With this formation of this product, the water as a byproduct. So this is the one side of the reaction. Our target is to prepare ethyl benzoate. We have initiated the reaction with benzoic acid plus ethanol. In acidic condition means water is there, sulfuric acid is there. We will get what? Ethyl benzoate plus water as a byproduct. Now in other side means suppose if you are having ester, that is called ethyl benzoate. Now when we are having ethyl benzoate, if you want to hydrolyze, then what we require? Hydrolysis means water. Normally hydrolysis of ester we can carry out in both the condition, that is called acidic condition as well as basic condition. Here we have taken acidic condition. So when we are having acidic condition, what we will get? We will get benzoic acid plus C2H5OH. So here when we are going to synthesize ester, at that time benzoic acid and ethanol react with each other in presence of sulfuric acid, we will get ester, but water as a byproduct will form. Whenever we are having water in a proper quantity, then what happens? The reaction will be reversible. So again from, as per the discussion of this reaction, again from ester, it will give you acid plus alcohol, means benzoic acid plus ethanol. It indicates that this reaction is reversible reaction. When this reaction is reversible reaction, then what happened? Can we get the 100% conversion? Means that is called ethyl benzoate we will get? No. We will always having the mixture of benzoic acid, ethanol and ethyl benzoate. So if you carry out a reaction for 1 hour, 2 hours, 3 hours or 5 hours or more, then also the reaction will not be completed. The reason is during the reaction water is formed and that water having tendency to hydrolyze this ester. So to avoid such problem, we have to think about other alternatives. Now in your mind maybe you are thinking that we have to use excess of sulfuric acid because sulfuric acid is also known as dehydrating agent. But when we use excess of sulfuric acid, its ionization will stop because sulfuric acid will act as a acid only in presence of water only. Okay, so only sulfuric acid is there, then it cannot be act as a catalyst for esterification. તમે જો આની મિકેનિઝમ જોઈ હશે તો એની અંદર સલ્ફ્યુરિક એસિડ એઝ અ કેટલિસ્ટ વર્ક કરે છે, H+ ડોનેટ કરે છે આ રિએક્શનને ઇનિશિએટ કરવા માટે. અહીંયા આગળ લોન પેર છે, આ પહેલા જોઈન થશે, વોટર રિમૂવ થશે and then after this alcohol act as a nucleophile and it will attack over here. This is the mechanism. એટલે કે સલ્ફ્યુરિક એસિડ જો એક્સેસ લઈએ અને બિલકુલ વોટર ના હોય તો આયોનાઇઝેશન જ ના થાય, તો રિએક્શન જ ના થાય. એટલે રિએક્શન સ્ટાર્ટ કરવા માટે પણ વોટર જોઈએ પ્લસ રિએક્શનની અંદર પણ વોટર જનરેટ થાય છે. સો ધીસ રિએક્શન is reversible reaction and to avoid such type of problem we have to use another reagent. Its name is DCC. What is the characteristic of DCC? It should be stored in an anhydrous condition. Why it is required anhydrous condition? Because it's a dehydrating agent, so it having tendency to react with water. When it react with water, then characteristic or property of DCC will be lost. So it should be stored in anhydrous condition only. Second, this is a potent skin irritant. So whenever you are using DCC, you have to take care or always avoid the contact with your skin. Okay, if it is skin contact, then definitely this DCC will trap water or absorb water from the skin, and as a result you will find irritation. એટલે કે તમને irritation થશે, એટલે કે ખંજવાળાવાનું શરૂ થશે, and it may damage the cells of skin. So whenever you are using DCC, we have to take care because it's a dehydrating agent. It will interfere with the water which is present in the cell. So it is known as potent skin irritant compound. It is a waxy, low melting solid. So it is easy to handle because if you want to handle sulfuric acid is liquid. Okay, so it is little bit difficult to handle, but this is a waxy, low melting solid, so we can easily handle. It is highly soluble in organic solvent. This is the most important characteristic. Organic solvent like dichloromethane, or another name is MDC, tetrahydrofuran acetonitrile, DMF. This is dimethyl formamide, means DMF. So this compound is highly soluble in most of the organic compounds. So when it is soluble in the most of organic compound, means whenever you want to carry out the reaction of benzoic acid, means this is organic compound, ethanol, C2H5OH, this is also known as organic compound, and your reagent is also soluble in organic compound like MDC and other solvents. So reaction will take place very smoothly. This compound that is called DCC is insoluble in water. It is insoluble in water, but it having tendency to absorb water. So don't create any confusion that it having tendency to absorb water means it is soluble. No, it is insoluble, but having tendency to absorb water. How it absorb water, that I will explain via reaction. So the compound already we have said its short form is DCC. Now how we can prepare DCC? C6H11NC means cyclohexane nitrile. એટલે કે તમારી પાસે કયું compound હોવું જોઈએ? Cyclohexane and triple 1C isonitrile. If you are having, then cyclohexane amine means NH2 C6H11 plus oxygen. When we are hitting this compound, all compounds, we will get this compound. Its name is DCC. N double one C double one N C. Sorry, nothing. Wait a minute. This we will get DCC. Then DCC also we can convert or get it from hydrated DCC. Hydrated DCC means here this is the structure of DCC. In this DCC, when water is enter, then what we will get? C double one O N H N H. This one is known as hydrated DCC. This hydrated DCC by heating with PTSA, para-toluene sulfonyl chloride, and in hot pyridine we will get the DCC. So these are the two methods of synthesis of DCC. Then thiourea type of derivative if is there, then by treatment with HGO we can convert it into DCC. Now applications of DCC, where we can use DCC. DCC is used for the synthesis of ester, synthesis of peptides, synthesis of peroxides, synthesis of amides, heterocyclization reaction, dehydroxylation of alcohol, alpha beta unsaturated ketone and esters, then synthesis of ethers and thioethers, and synthesis of diketones. Means with the support of or with the use of one reagent, its name is DCC, we can carry out several reactions. So these all reactions we can carry out with the support of DCC. So next time we will discuss in detail about the application of DCC with its mechanism, how we can use this chemical or how we can use this reagent for the synthesis of important compounds. Okay, if you are having any question or query, you can ask me at present, or next time we will discuss in detail. It is up to you. So do you have any question or query? Okay, if you don't have any question or query, then you are requested to leave the meeting. Let me download the attendance first. Okay, you can leave the meeting right now. Next Tuesday we will discuss again. Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you. I am ending the meeting because I am having another class.